thank you for joining this webinar about GenAI in finance powered by Elastic. So we'll see the architectures and the outcome. Um, we are very great to welcome you here, and we hope you will either learn things or want to work with us a little bit more later. A little bit more about Hyperflex, by the way. So who we are Hyperflex is an Elastic certificate partner, while funded by elasticians and Elastic engineers, and we got more than 20 Elastic certificate engineers into our team. We offer several services, which come from integration, consulting, managed services, and migration. Our engineers are all certificated by Elasticsearch, so which means we got more than 20 people with the Elastic certification. This is part of our mission to make sure that everyone, since we are an Elasticsearch partner, to make sure that everyone working with us is certificate, because we need to be recognized by Elastic to give you the best work we can when we deliver it. Where Hyperflex operates. Currently, our main headquarters is in New York, but we also got customers in Canada and Pune. Why choose Hyperflex? Well, I'd say we are a pure player about Elasticsearch. Our engineers are trust with the certification of Elastic, and we build, deploy, and support production-grade systems. The results you can expect to achieve will be saving at least 75K in 6 months, thanks to search and performance and unifying observability data. Also reduce search latency by 50% and operational cost by 75% through Elasticsearch upgrades. That's thanks to the business case we got, and this is what we already achieved with our customers. Now I'm going to let Aziz introduce himself. Aziz, you can go first.
Yeah, mic was off. Yeah, thank you, Nicola, for the presentation of Hyperflex. From my side, I'm an Elastic engineer as well. I'm certified on all the aspects of the solution, and basically, I have more expertise on the observability side, but I'm certified in all the aspects of Elastic. And I worked with the Hyperflex and continue working with it when it comes to the observability sides and the expertise. I basically have worked in the bank and telecommunication industry, which makes me a bit an expert in that field. And today we're going to be happy to talk about this first slide, which is the banks. This is for me, and I'm going to pass it over to you, Nicola, again.
Thank you. What about you, Naman? Can you introduce yourself too?
All right. Firstly, hello everyone. I am Naman. I am also an Elastic certified and observability engineer. Started as a DevOps engineer, have been using Elastic for mainly search and observability use case. At Hyperflex, I am working as an Elastic engineer, mainly working with financial and healthcare clients.
Thank you. I will take the share. I will let you, Naman, take the hand on the presentation so you can go deeper into it.
All right. Let me quickly share my screen. So I'm going to start, before we start with webinar, allow me to talk a bit about the products we are developing, right? We are actively contributing to Elastic MCP server and Logstash open source project. Other than that, we have been building some exciting products to cater enterprise problems, right? One of them is the Splunk to Elastic migration, right? So it is an enterprise tool which helps customers to migrate from Splunk cluster to an Elastic cluster. It has pre-built functionalities like pre-sales visibility logic with migration reports, multi-cluster support with both Elastic and Splunk, and a great SPL to ESQL query conversion for macro and lookup handling. Another tool which we have been working is the seamless upgrade. It is a fully automated one-click zero-time tool to upgrade Elasticsearch cluster, whether it's on-prem, cloud, and Kubernetes. Throughout my career, I have observed that upgradation is a pain point, and a tool like seamless upgrade will really help an enterprise client and really solve a real-world problem. All right, this was a quick update on, let's start with the webinar. Before we start, here's the hard truth, right? Most of the GenAI implementation in finance are failing, not because the technology doesn't work, but because they are built like a science experiment, right? Not as a production system. Look at this, right? This is a traditional banking architecture. Everything is structured, optimized for resilience and reporting, not for real-time insights, right? Core banking systems talk to a line of business applications which feed to a separate analytics and reporting layers, right? Its system has its own database, its own security module, its own API limitation. The fundamental challenge with something like this is the financial institutions are data rich, but inside pure. So you have terabytes of customer interaction, transaction histories, market data, but it is locked away in a disconnected system, right? When a customer calls for something like asking about the mortgage refinancing options, the agent usually can't just see their complete financial picture, recent market rates, and comparable loan products because the data lives in 6 different systems at that don't talk to each other, right? Meanwhile, something like compliance team is manually pulling reports from multiple databases, right, to answer a single regulatory questions. A loan officer is switching between applications just to underwrite a simple business loan, and risk management team, they are working with week old data snapshots instead of real-time risk indicator. This architecture works when banking was about transactions and record keeping, but now we are trying to deliver personalized intelligent customer experience on infrastructure that was designed for batch processing, regulatory reporting. It's like running a Netflix on 1990s mainframe, and the expectation has evolved, but the foundation hasn't, right? There is an inflection point, right? Just like we moved from mainframes to ATMs to online banking to cloud, AI is the next fundamental shift. But here's the catch. Most banks are approaching AI like they have approached their first websites in 1995. Show of hands, how many of you have seen a Gen AI POC that never made to production? Right? Exactly. The problem isn't AI, it's the architecture challenge underneath it. Large amount of data, limited customer insight, and trying to bolt Gen AI into legacy infrastructure that was never designed for real-time intelligence. When we talk about promise of generative AI, it is great, right? Gen AI is a great opportunity for each and every organization. The promise is massive: increase efficiency, improve customer experience, and competitive differentiation. But the difference between a promise and reality comes down to one thing: unlocking the real power of unstructured data, right? Our data is our MVP, right? When we talk about our private data, that is our MVP. Customer information goes far beyond demographics. Institutes have behavior patterns that reveal customer financial stress before even a customer realize it themselves. Product details include your institution's unique approach to risk assessment, specific underwriting criteria that differentiate an institute from competitors, right? The magic happens when you securely combine all this proprietary intelligence with AI models while maintaining data governance that satisfy your compliance team requirement. The Gen AI become an extension of your relationship managers. It knows customer history, understand the risk appetite, and follows proper business rule and provide great guidance, both personalized and profitable. The result, when a customer asks for investment option, the AI does not just suggest generic mutual fund. It considers your risk profile based on the actual behavior, their life stage based on the transaction patterns, available product based on the current inventory and profitable targets. Of course, keeping regulatory requirement based on the jurisdiction we are working on. That level of contextual intelligence is impossible to achieve with an external AI model trained on generic financial data. Here, Elastic come in place, right? This is how we can get, and let me break it down, how we can create a uniform platform architecture that is so powerful for financial systems. Look at this data flow. There's an Elastic ingest everything, whether it be structured or semi-structured or unstructured. Structured data, something like your core banking system data. Semi-structured, something like transaction processes. Unstructured data, something like loan files, regulatory files, or customer communication, even some real-time data feeds. But the ingestion is just a beginning. The platform enriches that data with machine learning as it comes in. Document classification happens automatically, and loan application get tagged differently than regulatory report. Entity extraction pulls out the customer names, account numbers, and risk indicators. A proper anomaly detection flags unusual patterns before they become the problem. This isn't just a batch processing that happens overnight. This is a real-time enrichment as the data flow through the system, right? Then you get the insight that you actually see when it comes to something like when we query, show me all the high-risk commercial loans in the manufacturing sector. The Elastic searches across the years of document, understand the context and the relationship, applies your security permissions, and returns this in few milliseconds, not in minutes, not in hours, just few milliseconds. A unified platform that ingests everything, enrich the data with machine learning, AI, provide real-time insights, and works across private cloud, hybrid cloud, and on-premise deployment. Let's transition with what actually is possible when you get your foundation right. Mainly, this can be break down into two categories. First is customer-facing application that drive the revenue, something like retail banking assistant, Q&A assistant, which helps you to improve personal finance, providing customized service and improved user experience. Employee-facing tool can be like a fraud detection summarization, which helps in anomaly detection and identify best actions, improved accuracy and efficiency, helping for early fraud detection. Both matters, right? But the employee experience use case is something which offered direct and faster ROI because they are easier to measure. Now, here's come the critical part, right? None of these happen without a right architecture. I would like to hand over the stage to Aziz. He will talk about how to get ready to deploy an GenAI app.
Thank you, Naman. I'm going to take over from here. And if you paid attention to what Naman was saying, it was basically showing you with one of the reasons why you need to use Elastic as a solution. And one of the aspects that he mentioned or he touched upon was the possibility to use the machine learning side of the Elastic stack to be able to detect the anomalies and classify documents and so on. But since we are talking about generative AI, we are basically implying that we are talking about something which is RAG or generative AI. And when we talk about generative AI, we basically have this need for context. And one of the questions that comes into our mind is, why should we use Elasticsearch as a database for our solution or for our generative application? Why do we have the possibility? We have all those possible connections that we can establish with all the components out there. For example, we can use other search engines, we can use APIs that are available within the organization, or we can use any MCP that is available out there. And if you remember the first slide that presented by Naman, he mentioned all the possible sources of information that you can get in the context of the finance enterprise. And when we talk, for example, about something that is like giving a loan or accepting a loan for somebody, you need to get a lot of information from different sources. So now the question that comes to our mind is, why should we put all this together and put it in one database that we can vectorize and enhance the search in it? Why shouldn't we not just leave it as it is and use it or query it using the MCPs or the available connections that we have with those databases? And to answer this, there are like 6 benefits of using that. And one of the 2 first ones are getting the right context and the relevance. And these 2 goes go hand in hand, because we are basically talking about getting the convenient information about what you are looking for. And in order for you to get that, you should define the relevance. You should define how you're gonna judge the data if it's the correct one or not. And in order for you to do that, you should not rely on the query or the search mechanisms of other solutions. You should create your own. And there is no other solutions than having your own database and having this information stored in a database that you control and on which you have much control when it comes to relevance calculation, etc. And here comes the importance of having a really powerful database that you can access either using the vector side or even the traditional BF25 or the lexical search. And another point, which is the point number 3, which is the access control. When you talk about something like the finance industry, it's an industry that is highly regulated, and the access to information is segregated across all the industry, across the organizations, and different people, different employees, different entities have access to different information. And in order for you to create those access control, if you have different connections, then it's going to be a hell of a mission for you. So the fact that you have everything centralized and created and put in one place would help you by leveraging what is available in terms of RBAC or access control, role-based access control in the Elastic Stack will make your life easier when it comes to how you can organize the access to this data. Another important point, which is the latency and performance. And this is very important because one of the main purposes why we are doing those generative AI is to kind of enhance or even replace humans' performance, meaning that we are caring about the response time that we're getting from those databases. And one of the powerful tools or one of the powerful abilities of Elastic is its ability to have a very low latency. Then we can also talk about point 5 and 6, which are leveraging the extra features of Elastic, and then the compliance and security. By talking about leveraging the extra features, we are talking about all the features that come together with the database. So we've talked about the storage layer, which is the Elasticsearch, but then we have everything that is around it, which is like, for example, the access control, but also anything that it comes to observability and when it comes to all the plugins that we can put together in order to enhance and make this tool powerful. And then for the compliance and security, there are many tools that are available in order for you to check or to make sure that your data is compliant, that you're not storing any personal information or you are encrypting it, etc., by leveraging all the tools that comes with the stack, or even developing your own plugins if need be. So this is like to answer why you need to vectorize your data rather than just using all the connections. So when we say vectorize, we also mean that why do we store the data? So the answer that we give to this is to take advantage of all the available tools and to stay compliant with all the requirements that are in the industry. So now that we established the need for a database or a vector database when it comes to the generative application that we are building, then we're going to talk about the layers that we need to have in our application. So in our application, we need to have a layer of ingestion, storage, generation, and then we need to observe this application. So when we talk about ingestion, we're talking about how we can bring the data from all the sources that are available within the organization and put it together in one place. And this layer can be divided into two layers. The extraction of information and then the layer of indexing the data. When it comes to the extraction of information, it is something that we need to adapt depending on what we have within the organization. If we have, for example, APIs, data stored in files, if we need to do any PDF scanning or reading, etc. But the second part, which is the indexing of this data, it is something that we need to define by ourselves, but the stack of Elastic gives us the possibility to use their existing tools of ingestion. We are talking here about, for example, the pipeline, the ingestion pipelines that allow us to parse the data and transform it and bring it and give it a certain format, etc., or even enrich it. But we also have the possibility to have the ingestion pipelines that allow us to parse the data and transform it and bring it and give it a certain format, etc., or even enrich it. But we also have the possibility to have the ingestion pipelines that allow us to parse the data and transform it and bring it and give it a certain format, etc., or even enrich it. some machine learning models that would take this data and transform it into vectors that we can use in vector search. Then we have the storage. For the storage layer, it's very simple. We can use the Elasticsearch database as the storage, and it gives us the possibility to have the BM25 search, which are the lexical search, and then also the possibility to have the vector search in order to ameliorate, or even hybrid search that would combine the two of these the type of searches in order to get the most relevant data. Then we have the layer of generation, and here we need to answer the question, what model should we use in our generative applications? And it is something that there is no general answer or generic answer for it. It is something that you need to test and then judge by testing all the available models and testing the type of models that you have, and also sometimes even testing the strategy or the definition of the generation. So if you go, for example, for a very naive application that is a RAG application, the generation will be simple, just a prompt. Then you gotta take the context and give it from the storage, and you generate the answer. But if we're talking about something that is more in-house or more complicated, in this case, we'll be talking about something that is more agentic model, where you generate the steps and then you take those steps and translate them to calls that you're gonna have to other tools, and then you take the responses and then you do the generation again. And the fourth layer, which is most important one, which is the observation and amelioration. And it is important because no RAG application, no generative application is meant to be operational from the first shot. It is something that we put out there, and then we, depending on the feedback of the client or the experience of the application with the client, that we ameliorate. So it's something that is always on amelioration. It is something that is enhanced on day to day. So basically, you need to have this observation and amelioration. And when we talk about the observation, we need to store the interaction with the client. We need to store the responses, the questions and the responses, but we also need to restore the metrics and the performances of the search layer, of the retrieval layer, of the latency, etc. And here comes the necessity of having something that would do all of this. And in this case, for example, can you leverage the observability side of the Elastic one, which gives us the possibility to do APM observability on application, on our application, that will allow us to monitor and observe our application from end to end, so that we can know what the client is asking for and what the application has responded, and to make the judgment. And later on, we can use this data to probably retrain the generation layer or change the queries that we have in the storage when we create the storage, etc. So it is a very important step, and I would say that it is the most important among all those operations, because it's the layer that is going to dictate how we're gonna define, how we're gonna enhance the other layers. So now that we have defined the layers, the next question that comes into our mind, we are building an application or an application. What exactly do we need, and who do we need in our team? So there are two. So basically, we need an AI engineer who put all of this together. Who's going to put the architecture, who's going to define what is the database, etc. But you need two most important skills in your team, and those skills are: you need somebody who knows your data and somebody who knows what the product would look like. And here I'm talking about the data engineer or data analytics engineer and the product owner. So the product owner is somebody who knows what they are expecting, who knows what the clients are expecting in terms of the outcome or the output they're expecting from your application. And the data engineer or the data analytics engineer is somebody who knows your data, who knows how your data is stored across all the means that you have in your organization. And this will dictate how you're going to bring this data, and how you're going to leverage it, and you're going to make it useful, and how you are going to store it. So that when the AI engineer comes in and orchestrate the whole pipeline of your RAG application or your GenAI application, then it will make the life easier to just address the data engineer rather than addressing each industry or each section of your organization. And then the functional product owner is here to give you like the specifics or the specifications when you start building the application, but also is here to judge or to tell you that the application is working, either the application is working or not. So if you have those skills in your team, now you are ready to start building your application. And the how would you achieve this optimally is by starting with no database logic. One of the errors that you see with generative AI applications or with the AI engineers is once you give them the field to start working, they just go ahead and start building. Here is the database, here is the vector search that we're going to do, and they start building. And I think this is not the right way to go about it, because first you need to start choosing the generative layer, which is the model. And how you do this, you can just go ahead and take a console and start chatting with your model and bring in the context manually. So for example, instead of you going ahead and creating the query that may not be relevant, you can just go ahead and write a prompt to your model on the console and then sending it the information that you deem relevant, and then you check the response. Once you are happy about the response, then you are sure that you built something, you built a prompt or you built a logic when you're talking about an agentic approach. Once you do that, then at this moment, the information that you brought manually, the context that you brought manually, you start automating it by creating queries that would query the database. And at this moment, if you are in step 2, then what you did basically is you have chosen the generation layer, and then you are successful when it comes to creating the context layer. And you have the 2 steps that are fundamental in your application. Once you do have that, then you can just create a POC, but you can put all of this together, and you can, at this stage number 3, you gotta put the observation layer so that you can continually enhance. You can continually go back to step 1 and 2 and enhance your queries, enhance your prompts, enhance your logic when it comes to agentic approach, and create something that you can scale later on. So this is basically like the implementation playbook that is available, or that can be applicable to any generative application that you're building, but is more applicable when it comes to this industry. Now, when it comes to how we can test the application, or if you have observed our application, and now we are talking about how we can make sure that what we build has value, then we have an example here that we worked on. We changed the names, we changed everything so that it can look different. But basically, the KPIs that you need to take into consideration are, and we're talking about the industry of finance here, is the research team. So for example, if we're talking about loans, the time that it takes an agent to go ahead and assess the validity of a loan application needs to go drastically. So for example, if here we have an example where it went from 8 hours to collect all the information, analyze and put it together, and then decide whether the loan should be given or not. We have brought it from 8 hours to 45 minutes, which is a very good KPI. And then we have the accuracy, which means, for example, in this case, or in this example that we're talking about, is how many errors were made by the model when it comes to assessment. It means how many loans did it give that it should not have given. Then, so these two are can be measured directly, but then we have the user adoption, revenue impact, and ROI, which are more complicated KPIs, because user adoption is going to be something that you would have to assess within your organization. It doesn't only depend on the performance of the application, but also on other parameters like if you are allowed and regulations, etc. Then revenue impact, it will just be directly, it is correlated with the research time, because the more you treat, the more loans that you have treated, the more you will have revenue. And then the ROI, which is how much it took for the initial investment to be brought back. So this was an example of GenAI application, and then the KPIs that we put in order to measure its performance, and it is something that you can use also in your in your finance application or in your finance GenAI application in order to measure its performance. So now that we have covered all this, I'm gonna let Nicola take over for the Q&As.
Indeed. Thank you, Aziz. Thank you, Naman, for this amazing presentation. So let's switch back for the Q&A. So yeah, just we got like one first question was already in the chat. So which one do you want to start? Maybe
Yeah, sure. I can take it. So if we talk about the integration of Elasticsearch with something like uh, Azure or Microsoft Fabric or ThoughtSpot, there is no direct integration available, but it is possible with some technical implementation. For example, for ThoughtSpot, we can use something like JDBC plugin or API based plugin connector so that we can pull data or push data, right? So there is no straightforward integration available, but there is workarounds that could be possible.
you want to add something, Aziz, maybe to complete? Or
Yeah, I think Naman had a great answer for this. In Elastic, you have like integrations that allow you to get the data from elsewhere. But if there is no integration that allows certain specific software, that you can use or you can code your own.
thank you for this. We got another question. So, how do you see GenAI evolving in finance over the next 3-5 years in the focus more on augmentation of analysis, analysis or full automation of decision flows?
Yeah, I can take that one. I think there is no doubt that the GenAI is going to be the next big thing, and it's already the big thing now. But when it comes to the finance industry, I think it's a very regulated industry, and when it comes to adopting certain technologies, namely the GenAI solutions, there is you basically and rapidly hit the wall of the regulations. So, for example, if you talk about Europe, you have the GDPR regulation that you need to stick into, you need to, the AI laws, etc. So it's not only a matter of like the technology and its value, but also the how it can stick to the regulations. And so I think the future of GenAI in the finance industry or in the banking industry is highly dependent on the evolution of the laws. So if the laws and the regulations evolve as fast as the field is evolving, that we can see the adoption quickly. Otherwise, it's going to be there's always going to be a gap between what we achieved and then where we are in terms of implementation. Do you agree with this, Naman?
Yeah. The financial sectors usually go slow with new technology. They are more cautious and they want to comply with different compliance and regulators information. But I have seen that many financial institutes have started adopting GenAI, especially like big enterprise financial institutes have started to use GenAI for chatbots, customer service and stuff, which is slowly and steadily uh, uh, grabbing its foot. And I'm sure that this would be a great opportunity for more financial institutes to try out GenAI and help their customer for best experience.
We got another quick question from Gaurav. So, how making sure that sensitive data, especially for the industry, which are highly regulated, not ingesting the customer logs in LLM model to train the model?
This is actually a great question. Thank you, Gaurav, for asking it. When it comes to the sensitive information or the PII information that you store within the Elasticsearch, there are two ways to go around this. So basically, before going to the database, you have the controls in the ETL layer or the ingestion layer where you can define, for example, certain rules or certain sequences of roles that you can apply on the data that you get before going to Elastic. So if you have something, for example, if you have fields that say, for example, let's just say account number or something like this. So before going to the search engine, we can encrypt it, or we can replace it, or we can even remove it if it's a field. Then you have something that is more complicated than that, which is like, for example, if you have a paragraph of data and the personal information or the sensitive information is mentioned within this paragraph of data that is only stored in one field. And in this case, it becomes more complicated because you need something to analyze all this field. And to do this, you need to make it go through a machine learning model. And there is something also that is supported. So what you do is basically, before taking the data into the next steps, you just put something in the between, and you say analyze the whole data and remove or replace the sensitive information with asterisks. Of course, this would come with the price, and because it's going to be a call for the API, you're going to consume the number of tokens, which is more costly when it comes to this type of tracking information. So generally, what people do is they use the guardrails in the retrieval of the information. So instead of like making the information obfuscate the information when it comes to the ingestion layer, what they do is they put the data as it is, and they store it as it is. But when they retrieve the information in the model, they put guardrails and say, whenever there's an information that is personal, that defines as this, etc., with the certificate that you define, then obfuscate it and replace it with this type of this logic of information. So to wrap it up, there are three possibilities. You can either use static replacement when it comes to fields. You can use email machine learning models so that you can analyze the whole text, but it's costly, or you can use it at the retrieval stage. And I hope I answered your question, Gaurav. Before we go to the next questions, I just want to ask you, how many people here are using Elasticsearch? That's in the comments that we can use for later on. If you can just put this on the chat. Naman, do you agree with what I have said, or you want to add something?
Yeah, you have covered pretty much. You can always host your own foundation model to just make sure that you don't have to call an API. You can always host your foundation model on your own on-prem infrastructure, making sure that you are not providing your regulatory and compliant data to a third party, right? So there are various open source foundation model available. You can fine tune that. You can use RAG upon that.
Yeah, and this is something also that is very specific when it comes to the backend industry.
Yep.
You are very limited on the models that you can use because you can export the data outside of your industry. So basically, what you do is you will create this entity in your site. So instead of like you calling the OpenAI, you're gonna build your own quote unquote OpenAI locally. But when it comes to cost, it's not generally. I'm not talking about only the API call or the cost of API call. I'm also talking about the infrastructure they will have locally, which you can always translate the number of calls on average for the year, because you are always limited on how much you can achieve or how many calls you will have, depending on the infrastructure that you have.
The next question comes from Benjamin. So, in terms of fraud prevention, do you think banks will start leveraging AI for that purpose?
Sure, I can take that. So if we talk about fraud detections, banks are already leveraging AI extensively for fraud prevention and detection, especially something like anomaly detection algorithms, where we recognize the pattern for unusual transactions or velocity checks. We currently, banks and financial sectors are using machine learning models to detect such patterns, to analyze such pattern, and be proactive rather than waiting for an incident to happen. So yeah, it is possible, and banks are using it.
Yeah, and yeah, this is like one of the powerful tools when it comes to the stack of Elastic, which is also going to answer the question of Gaurav, how real-time threat detection is leveraged. So basically, what happens is you will have a model within the stack that you train on your real-time data or on, let's say, base data, And what happens is whenever there is a new data that's coming in, it will analyze it depending on what the training that happened before. And if there is an outlier, if it's an outlier, then it will just tell you there is a high chance that this data or this document or this information is an outlier. And it will continue training this model so that it can detect the trends, if there are any trends within your data, etc., so that it reduces the false positives. So this is one of the positive side of the machine learning in the stack. And just to be sure, in here we are talking about two things. We are talking about the generation, and we are talking with machine learning. So probably they're the same thing, but here when we talk about generation, we are talking about like models that would generate the data. Machine learning, we are talking about use cases such as threat detection and what is it called? I lost the word. Prevention.
How real-time threat detection is leveraged in Elastic or Hyperflex?
Yeah, I think that's the one that I just answered. So I think there is another one.
Oh, sorry. We got how do you balance transparency and explainability of GenAI outputs with the black box nature of large language models?
Okay. Okay. So this is one of the challenge, especially in something like highly regulated industry. So Gen AI or AI or foundation models can act as a black box. We never know what could be the next probability, right? So yeah, fundamentally LLMs are black box, but uh, we have different guardrails. We have different frameworks which we can use to make sure that we have proper understanding of any decision making process, right? We have to make sure that there is a transparency between the retrieval layer, there is proper transparency between different layers of something like RAG or a GenAI app. There is some confidence scoring going on, there is some human in the middle to make sure that there is some validation as well as scoring to make sure that the generation, the answers, or any actions are validated before making any changes.
We're going to get like the last question, I guess. So, um, are there architectural patterns you have seen work best when deployed RAG in finance?
Yeah. So I can answer the opposite question, which is the patterns that do not work.
Oh,
Yeah, I think that the one thing is sure is the naive approach is never going to work when it comes to the finance, because in finance you have, I would say, you need to take into consideration this hybrid agentic approach. You will have data that you need to search using the keyword, you need data to search that using the search, and then you need the data to search using the vector search. There is some data that, for example, if I'm looking for a loan, there is some information that you need about me that you need to get using my exact name. And for this, you need to use the exact keyword search, etc. So you cannot just take the whole query, give me is Aziz able to pay his loan, and then send it to the database and expect to get all the information or the context that is applicable to me. You need to divide this query or this quest or this request into multiple requests. The first one is going to be the very sensitive information that you need to know about me. The second one is going to be the medium information. And the third one, which is the vector search, which is all the relevant information that you can get about me out there that is relevant or not, but it's not that sensitive or that risk. So if you use the naive approach by taking all of this and just dropping it on the model, it's not going to work. So you need to have this agentic approach. You need to take the query, analyze it, and have like a very agentic approach, and then send all these queries and then gather them and then recreate this approach. I think this might work, but the naive approach is never going to work in this context. I don't know, Naman, if you have a different point of view on this.
Yeah, you have pretty much covered everything. But something I have done to make sure that our RAG application is working all right is playing around with our chunking strategies, playing around with the embedding models, right? We have to do proper A/B testing to make sure that it is what we want. We have to have proper scoring, relevance scoring, right? To make sure that there is no false negative and stuff, right? So proper chunking strategy, embedding models, testing, proper A/B testing, what we usually do in a software engineering environment, we can do and have in place to make sure that our RAG application is retrieving and giving us information at its best.
Thank you very much. So to conclude briefly on this, if you want to check all the other webinars we made, you can check it right on our website. We also made meetup, we made podcast, and other kind of events. You'll get access to all of it. I will also put in the link I'll put in the chat all the links to join us on that. If you want to present the next webinar with us, you can also reach out to us to be the guest or the main speaker of it. So let us know about that. Thank you. And one last thing for all of you who join us for this until the end, you will receive a certification at the end by email. So we'll send it to you to thank you for joining us today and to listening until the end. I wish you to have a nice day and thank you for joining us again. Bye.